My name is Aidan Andrews, and this semester I researched embodied intelligence in humanoid robots. The motivation for my research was LLMs have strong textual intelligence, but lack the ability to reason in the real world and interact with it. So my goal was to create a hierarchical System 1, System 2 intelligence akin to biological intelligence. Some of my challenges were no methods for teleoperation, no training data, and a single VLA often fails for both manipulation and locomotion tasks. So my project timeline started in September when I was setting up my infrastructure. This involved getting used to Isaac Sim and Isaac Lab, researching locomotion policies and VLAs. In October, I actually started integrating some of my research. In November, I worked on teleoperation methods. And then in December, I finally got a working deployment of Groot on the G1 in simulation. So initially, I tried to train Groot on data I found on the internet. This was a very established data set collected on a real G1 robot. It was a pick-place data set with thousands and thousands of trajectories. The problem was that it was trained in the real world, or the data was collected in the real world, and I was trying to deploy in simulation and with a slightly different task distribution. And so the model just pretty much outputted randomized actions. And so I needed to diagnose what the issue was. I didn't know if Groot was the problem, if my data was the problem, if my simulation was the problem. So I used an SO101 robot and collected teleoperation data directly on the physical robot, and then also deployed Groot directly onto the physical robot. So no simulation, no middle steps, nothing, just straight teleoperation to deployment on the physical robot, and it worked. So we know something in my pipeline was the problem and not Groot. So I needed to devise a way to collect teleoperation data on the G1 in simulation. All I had was a webcam and the robot in simulation. So my approach was to convert webcam video to robot actions. After some research, I found Video Mimic, a project out of Berkeley, which does a full real-to-sim, sim-to-real pipeline. I only needed a small portion of the entire pipeline, namely SAM2 for human segmentation and tracking, as seen on the left, and VIT pose, seen in the right image. So the status was the pipeline works, but retargeting to G1 joints was very, very complex. So I had a problem. I couldn't convert the extracted data into robot actions, at least in time for the end of the semester. So I needed another way to collect teleoperation data. And this is where I found the MetaQuest 3 and Unitree XR teleoperate. So my solution was to use direct VR control of the G1 in simulation using the MetaQuest built-in hand and arm tracking. So I collected a data set of 14 episodes, and then I tried two different training paradigms. One is like a quintessential, really large deep learning train, and then the other one was a LoRa fine-tune. So the LoRa fine-tune used an order of magnitude less training steps and was much more restrictive in the weight updates. So the full fine-tune, we did see strong drop-off in the loss, but then it flatlined, the classic sign of overfitting, and then the LoRa was more steady, loss decay all the way up until the end. The actual implementation of the full fine-tune can be seen here. In the bottom left, we have an image where the robot basically just plateaus to a single control action, which is very, very strange. So that's what motivated me to actually do the LoRa fine-tune in the first place, but then the LoRa fine-tune led to a successful deployment. Here's some teleoperation episodes. So as you see, I just flicked the block into the square, and then another one where I picked it up and actually placed it. So here is Groot after the LoRa fine-tune operating. So there are some kind of chaotic actions, but as you see, it flicks the block into the square as directed and as seen in training data. So the key takeaways were data quality matters much more than model choice. I needed to learn how to diagnose systematically, so using the SO101 as a testbed, and then LoRa fine-tune was much better than the full fine-tune for small data sets, especially with 14 trajectories. And then simple solutions often win. So the MetaQuest solved my problem much better than, or much quicker than the webcam to teleoperation could, although the webcam to teleoperation does allow full body movement, and the MetaQuest only allows for dexterous manipulation. So my next steps are to integrate LeVerb, which is a full body VLA, but I want to leverage just it for locomotion. Data scaling, so DreamGen is a method for generating synthetic data off of your existing data, and then collect more teleoperation data. Long term, as you see on the right, I want to develop this whole System 1, System 2 setup. Closing, I built the foundation for my hierarchical humanoid intelligence. I went from zero teleoperation capabilities to working VLA deployment. And then finally, foundation model plus right training strategy plus good data equals results. Thank you.